Start the clock.
I was like, I don't even know.
Okay, super quick. Let's. Yeah.
No.
Okay, I just want to take a quick look at. Here's the assignment. Here, and I don't want to spend any time on this. I want to just talk about quickly. Say how do we do this? You know, and then you guys can go do this stuff. We'll get it done. Okay, so complete the equation to write an exponential function of the form y equals b times m to the x. Instead of calling it a times b to the x like our textbook does, it's just b in this case is the number out front, right? That's going to be the constant multiplier. I mean the initial value or start value. And whatever number is inside the parentheses to the x, that's the one that's going to be, we multiply that every time x moves up by 1. Another power, we're just going to multiply again by that. So that's the constant multiplier. And so they're essentially just giving you this stuff here. You're just plugging it in. 14 is b, that's the start value. Constant multiplier is 10, that's m. Done. Okay. We're just getting some practice writing these functions is all this is about. Same kind of thing here. They're just different values, but they're giving you start value, giving you a constant multiplier. Would I even write the 1 in there if that's the start value? I mean the initial value or start value, and it's what I multiply by. Do I multiply by 1? Wouldn't even write it. This one would just end up being the quantity 1.1 to the x. Okay, with these, you're supposed to take this information and turn it into an exponential function. So quickly now, what's the start value going to be? Well, it's the y value when x is 0. That means you're on the right track, right? So it's 8. It's 8. Whenever x is 0, that's telling us the initial value of the function, the initial y value. Now, what's the constant multiplier? How do you know?
3.
Say it again. 3. Yeah, because that's what I'm multiplying by to move down the table, right? So then all this is y equals 8 times 3 to the x, right? That's all it is, okay? Oops. Okay, same kind of thing here. Here's the initial value, 17,000. Now if, what's it say here? Each year she has the car, the value is 0.9 times its value in the previous year. So what's the constant multiplier? 0.9. Yeah, so it starts off $17,000 times 0.9 to the x. And then we'll just plug in values to plug in 8 for x to find out what the value is after 8 years. Okay. And then these right here. All they're asking on these, don't make these harder than they are. They just want to know if I write this as a constant multiplier, what is it? So let's just look at maybe 1 or 2 of these. So appreciating by 21%. Remember that if we're going to write, you're going to use a percent increase or decrease, we write 1 plus r, where r is, that's our constant multipliers, 1 plus r, where r is the percent change as decimal, right? So if it is appreciating, positive or negative, going up, 21% is what as a decimal? 0.21. So it's 1 plus 0.21 is our answer, right? That's all they're saying. Oops. write the constant multiplier for the situation below, going up 25% per second. 25%, or the per seconds makes no difference. All we care about is it's going up by 25%, right? So in this case, what would the constant multiplier be? 1.25, exactly. What if it's decreasing by 42%? Let's look at one of those. Those are just a little harder. So what's the percent change as a decimal? 0.42. So we're going to do 1 plus negative, so minus 0.42. Right? It's going to be our constant multiplier. So what's that going to be? 0.58. Right? Make sense? Okay. That might be all we need to do. I think it probably is.
To the left.
I think that's it. Yeah. Okay. To the left. 205.